Okay, on this example, they're giving us an equation, and they're saying find dx dt at x equals -5 of that equation, and dy dt is -5. So here's the equation. We're going to have to do on this problem and everything in this section of related rates, implicit derivatives. We're going to have to take it implicitly. And we have that section back in chapter 3, implicit differentiation. What is it? When do you have to, how do you know you're supposed to do it? Well, it's when the derivative is with respect to a different letter in the denominator. So, for example, let me give you some examples. See this example here? Here we have, the same equation as this one, right? Here's the other equation. Suppose we want to take the derivative with respect to x. Now, I know I haven't talked much about that fractional way of writing derivatives, but now I'll mention just a little bit about it. D means difference. It's a D standing for difference. So we're saying the difference in y with the difference in x. Now think with me for a second about this. You know about driving your car 50 miles, 50 mpg. Sorry, mph. That's 50 miles per 1 hour, right? You're going down the highway 50 miles per 1 hour. Now, you also know about a car that gets 40 miles per gallon mpg. That means you get 40 miles down the road for every 1 gallon of gas. It's pretty good gas mileage, right? Now notice both of those are rates. What do you mean rate? And we mean times on the bottom. It's how fast something happens, right? We go 50 miles down the road every 1 hour. So 100 miles in 2 hours, et cetera, et cetera. Or this is also a rate. We go 40 miles down the road for every 1 gallon of gas we burn, 80 miles for 2 gallons of gas, et cetera, et cetera. They're both rates. They both have miles on the top, but notice they have different units on the bottom. They're different concepts or ideas. Miles per hour, how fast you're going, and miles per gallon, how fast you burn gas, right? Well, that's what goes on in the real world with rates. So somebody can ask you to take this equation right here and take the derivative with respect to x. Like how fast does y change as x changes? Like how fast do miles change as hours change? And if you're going to do that, notice that these right here, this letter and this letter are the what? They're the same. So if they're the same, then you just do the derivative like normal, right? We just bring down the 2 and it's just minus 8x minus 0. So, and so we would say y prime, right? dy dx, as I'm just rewriting it here, is y prime equals -8x. No big deal. Now, on the second hand, down here, we're going to start with the exact same equation, but instead of, excuse me, taking the derivative with respect to x, like miles per hour, we're going to do miles per gallon, something different. We're going to do d dt. We're going to say, what's the difference in y, descents or difference again, as time changes with the distance in time. I guess that would actually be this first example, whatever. We're doing something different. Now, notice in this case that this letter and this letter are not the same. Now we're doing the derivative of this right side, minus 4x squared minus 5, with respect to time, which is not the same letter. That's when you've got to do it implicitly. When you're doing a derivative with respect to a different letter in the denominator, different letter in the denominator. See how t here is a different letter than x, whereas on this one, x and x were the same. So how do you do it? Well, you just bring down the 2, minus 8, x to the 1, but then dx dt. And then the 5 is just 0. We know that. You see, you might wonder, where'd that dx dt? We didn't have one of those here, right? Because right here, it was not implicit differentiation. These guys were the same. But here, these guys are different. So it's going to be dx dt. Remember how we had to do that? Because x is a function of time. So just like back in that chapter, remember how we always treated y, we'd always go minus 8y, y prime. Now we're doing that with x and y in this chapter. Why? Because everything's going to be with respect to time. So x is a function of time. Y is a function of time. So all of our derivatives in this chapter are with respect to a what? To a different letter in the denominator. When you do that, that requires an implicit derivative. So let me erase this and let's do our implicit derivative. So, all right. So I'm going to come in here. I'm going to go prime on this side. Prime. Now, when I do it, I'm really doing dt on both sides. I'm taking the derivative with respect to time. How do I know? Because they told me they want time on the bottom. And these are different. This Y is not T and X is not T. It's a different letter, so it's going to be implicit derivative. All right, so what happens? Well, I'm not going to write all the fraction notation. I'm just going to, okay, this is Y prime. The other side going to bring down the 2 minus 8x, subtract 1 from the power, but then times x prime, and then minus 0. This is just going to go to 0 because the derivative of a constant number 0. Yeah, see how we get this x prime here? I know that probably looks weird. You're like, I bet you're thinking back on Mr. Didn't we only do that for y though? Right, it's true. Back in chapter 3, near the end, it was 3.8 or something. Can't remember exactly. We only did it for y, not for x. But in this chapter, we're going to do it for both x and y because both of them are with respect to time, dt, and neither one is time. Back in chapter 3, excuse me, we were taking derivatives with respect to x on the bottom. So when we came to the x, well, that was the same letter, so we didn't need to do the implicit thing. But in this chapter, it's all about time. It's all about time. So we're taking derivatives with respect to time, and neither one of these are t's. So both x and y are treated with implicit differentiation. All right. So with that in mind, then, what are we supposed to try to find? Now, if they tell me dy dt is -5, so that goes right there. Y prime is dy dt. And minus a, and what is x? Tell me right there. X is -5, right there. And x prime is actually what I'm looking for. Find the x dt. So what do we got there? So -5 is 40. X prime, finish solving for x prime, divide by 40, boom, boom. X prime is -1. You know, if you reduce that fraction, if you divide top and bottom by 5, it's -1. Or you can get a decimal. That'd be fine too. And there's the answer, -1/8. So that's what I have to do. So you have to remember in this chapter, everything's going to have time on the bottom. We're doing like miles per hour. We have time on the bottom, and x is not t and y is not t. So it's a different letter than both of them. So that requires implicit derivatives for both x and y, meaning we get this kind of thing happening. All right, there we go.